Alright guys, welcome back to my channel. So going to the next question. If you're probably watching this video for the first time, it means you probably missed the first video, and we did something very simple under Picard method of approximation. So you can kindly subscribe and turn on the notification bell so that you can get notified when we solve any question related to numerical analysis or any math related course. So for this, you have find the third approximation of the equation dy over dx equals 2 minus y over x, where your y equals 2 and x equals 1. Don't forget, in the previous solution we stated that anytime you have this, it implies your y naught equals 2 and your x naught equals 1. Straightforward. You should know that. It is important that you know that. Then you should also know the nth approximation formula. Excuse me. What else did I say? Okay, then I have this node on integration. So here we're doing one funny integration here. It's just the scope I'm going to teach you, so you don't have to do the full solution. So here we have our dy over dx equals 2 minus y over x. It implies that, you call your IVP, initial value problem, that your f of x comma y equals dy over dx, which means if this is equal to this, it implies this is equal to this. So dy f of x comma y is equal to 2 minus y over x. And then we can recall that our yn equals y naught plus integral from x naught to x f of x comma yn minus 1 dx. And don't forget, I said you don't have to cram the formula. Just know that when you have your y of n is equal to y naught, this y naught is constant, then you're integrating from x naught to x, then this will only change, because if I have y2 here, then it should be y1. If I have y10, it should be y9. So just using by 1. So that's all about the formula. So now, since you already have what you want to use, it's so easy. You just go through the normal step. Now the first thing is looking for the first approximation. We're going to be 3, or the third, excuse me. So the first one, that means your n equals 1. So I'll put, anywhere I see n, I put 1. So I have y1 equals y naught plus integral from x naught to x f of x comma, what will I have here? Y naught, y, because n is 1 minus 1 is what? 0. So therefore I say my y1 equals y naught plus integral from x naught to x f of x comma y naught dx. So now we already have this. It's straightforward. I just have to know that my y naught equals what? Oh, this is it. Y naught equals 2, and also my x naught equals what? 1. So I come to my formula, or my approximation formula, and I have y1 equals 2, because my y naught is 2, plus integral from, what's my x naught? 1 to x. Now what is my f of x comma y naught? If you watch the previous video, when you have f of x comma y naught, it implies, since you have f of x comma y equals 2 minus y over x, it means I just have to change the y here. I'm using y naught. It implies this y will be y naught. If I have y9 here, that means this y will be y subscript 9. So here it is y naught, so it's going to be 2 minus y naught over x dx. So then y1 equals 2 plus integral from 1 to x, integral of 2 minus 2 over x dx. So y, because y naught is equal to 2. So now I have to integrate. So when you're integrating, if you have integral of 1 over x, it implies if you integrate this, you have it to be ln x. So if I have 2 over x, it's equivalent to 2 times 1 over x. So therefore I can say 2, this is, if I integrate this, I have 2 ln what? X. So now that means here I have y1 equals 2 plus, if I integrate 2, I have 2x. Now integrate this, I have minus 2 ln x. So dx, oh sorry, excuse me, if integrated you don't have to put this, excuse me. So this is 2 plus 2x. Okay, yeah, you integrate, this is your normal 2, sorry, excuse me. So this is your normal 2, you have your 2 here. If I integrate 2, I have 2x. If I integrate this, I have minus 2 ln x. Then I told you minus is equal to x from 1 to x. So therefore I have to put it here. That means that I subtract from the bigger number to the lower number. This is where it's going to end, but we only know the starting point. So the starting point is 1 and the end point is x. We don't know. So you start from the biggest. So this is, you're going to subtract from the bigger number to the minus the lower number. So that means my y1 is equal to 2 plus 2. That means anywhere I see x, I put x. So 2x minus 2 ln x. Then I'm subtracting. I've done the first one, which is x. The second one, which I have to do, is for 1, value 1. So that means I will have it to be minus 2 into brackets 1 minus 2 ln 1, and ln 1 equals 0. So this will just truncate it to go away, 0. So I can see my y1 equals to 2 plus 2x minus 2 ln x minus this 2. This has turned to 0. So therefore my first approximation is, this what it's 2 minus 2 is what, 0. So I'll be left with 2x minus 2 then x. This is my first approximation. Moving to the next, second approximation. Don't forget that your y1 equals 2x minus 2 ln x. So it is important because when you're dealing with y2, it implies that here you have your y to be y1. If you remember the way I said, you should always do it. So we have y2 equals, what's our y0 from the question? 2 plus integral from 1 to x, 2 minus y1 over x dx. And what's our y1? This. So therefore I can just say this is equal to y2 equals 2 plus integral from 1 to x, 2 minus, will I still write y1? No, I'll just look for where my y1 is, and I can recall that my y1 is 2x minus 2 ln x, now over this x. That's why I have it like this, dx. So my y2 will be 2 plus integral from 1 to x, 2 minus, now okay, don't yet open the bracket. So if you want to integrate, it is better actually to just divide, like make it stand alone. So I divide both sides by, like, I want it to stand alone because this is the same thing. This here is the same thing as this. If I take LCM, see the same thing, so I'll still get this. So therefore I just want to write it in this manner. So I have 2x over x minus 2 ln x over x. It's still the same thing as this. So now I can have my y2 equals to 2 plus integral from 1 to x, this 2 minus, I'm opening the bracket. Now this x will cancel this x now, right? So I have 2 minus 2, right, plus 2, because this is it, 2 minus this 2, minus times minus turn to what, plus. Then I have 2 ln x over x dx. So now, all right, so when you want to integrate something like this, the scope here is just that you don't stress yourself. When I have ln x over x and I'm asked that, madam, please integrate this, what you just need to do is, what is the power of this, everything here, the power here is what, 1. Entering to power 1 is still that thing back. If I have 1 million or 1,000 raised to power 1 is still 1,000. So now I'm having ln x, the power here is what, 1. So since the power here is 1, when you integrate this, just know that it will give you, what you just do is increase the power by 1. 1 plus 1 is what, 2. So that means I will have, then when this is the step, okay, let me take it slow. Increase the power by 1, so I have 1 plus 1, which is what, 2. So I'll just write 1 over total 2, then ln x squared. When you integrate, this is what you're going to get. Now let me explain again in a better way. So that means if I have ln x over x raised to power 3, what are you going to do? I just increase this by 1, so that will be 4, right? So I'll have, if I'm integrating, so it'll be 1 over 4 ln x raised to power what, 4. That's the answer when you're integrating. So I hope you get it now. So that means here the power here is 1. Excuse me. The power here is 1. So it implies that when I integrate this, let me start from the left hand side first. So my y2 equals this 2 back plus integral from 1 to x. This is 2 minus 2 turned to 0, right? So I have 2 ln x over x dx. So now if I want to integrate this, so I have it to be this 2 is what I have here. I'm bringing this 2 out, so I have this 2 here. So then I still write my integral back, 1 to x ln x over x. And don't forget, I said dx. If you just look at the power here, the power here is what? 1. Increase it by 1. That's why I said here, if I integrate, this is 2 here, normally, excuse me. So y sub 2 is equal to 2 plus this 2 here, this is it here. Now multiply by this scope here. I taught you 1 plus 1 is 2, so just bring 1 over 2 multiply by ln x all squared. Then you take your integral from 1 to, you subtract the biggest number minus the smallest number, or the smaller, this is bigger than the one than the one here, excuse me, because this is the end point, this is the beginning, the starting point. So that means I subtract the smallest from the biggest, excuse me. So you understand the integration here. If you don't, you can comment and ask questions. I'll definitely reply. So what else? So that means your y2 is equal to 2 plus this 2, we chop this 2 here. All right, this 2 we cancel the 2 here. So I have y3 equals to plus integral from 1 to x of 2 minus 2. You have to put this in bracket because it's your y2. Now going to the next page, we have y3 equals to just the same thing. Since you have it as your y2 to be equal to 2 plus ln x, that means everything should be over x. Now if everything is over x, it implies I can separate it to be 2 over x plus ln x squared over x. Still the same thing, right? Alright, so that's what I did here. That's why you can see that I used 2 plus integral 1 to x, 2 minus 2 over x minus ln x all squared over x. And I gave you the scope already for this, that when you have, if you are going to integrate this, what are you going to do? Just increase the power by 1. So this will be, if you're integrating this alone, I'll have it to be 1 over, because this is 2 plus 1, 3. Then I'll have ln x raised to power 3. So this is the integral. So you should just keep that here. So going to this, I have my 2 back. Now I'm going to have to okay, now I'm going to have to integrate this. So if I integrate this, it's going to be 2x minus 2. This is, we've done this before, so this is going to be minus 2 ln x. Then this here. So now we can move smoothly. So I have to, anywhere I see x, I put x, and anywhere I see 1, I put 1. That means anywhere I see x, I put x. Then minus anywhere I see 1, I put 1. So anywhere I see x, right? So from here, this is 2 plus this 2 will stand on its own. Actually, you're not using the boundary for it. So this 2, then plus anywhere I see x, right? So this will still be x, 2x minus 2 ln x minus 1 over 3 ln x all cubed. Then minus, coming to this place back. So I've done x remaining 1, right? So here I'll have 2 into bracket 1 minus 2 ln 1. I didn't continue this because you know that ln 1 is what? 0. So here 0, here 2 will be 0. So that means here will be 0, here will be 0. I have y3 equals to 2 plus 2x minus 2 ln x minus 1 over 3 ln x all cubed minus 2. So this 2 minus 2 will turn to 0. So I can automatically have 2x minus 2 ln x minus 1 over 3 ln x all cubed. So that's the solution to this question. So I hope you guys understand. If you have any question, you can drop it in the comment box. I'll definitely explain better. And if you have any other videos you would like us to make, do well to tell us, as we're going to make that as soon as possible. So don't forget, when you have your question, all you just need to do is take the things you need, which is your y over dx equals this. Then know that when you have y equals 2, it implies your y not equals to 2 and your x not equals to 2. Then you remember your nth approximation formula, and that's all. Thank you for watching the video. If you do like it, you can subscribe, and have a nice day.